Good morning, students. Our class will start with Pythagoras theorem. This is from chapter 12 of class 9th maths. We will start with the triangle. In a triangle, the length of sides opposite to the angles of the triangle is comparatively greater when the angle is greater. That means if the angle is greater, then the side opposite to this angle will be greater. Like here we have a right angle triangle, and this in this triangle the angle B is 90 degree, which is the greatest angle. So we will say that the side opposite to angle B, here you can see the side, this AC is opposite to this angle B, that means the greatest angle, that is 90 degree. So this side will be the greatest side, the side with greatest length here AC is, and this one is called hypotenuse. This AC is called hypotenuse. So here we will say, see, this H is greater than this side A, that means this AC is greater than this A, and this H is also greater than this B. Okay, now see this one, Pythagoras theorem. So what Pythagoras theorem tells us? Here you can see the condition. Okay, so according to Pythagoras theorem, when we have a right angle triangle, then the square of the hypotenuse, that means the square of the greatest side is equal to the sum of the squares of the other two sides. Like here, this greatest side, square of the greatest side, h square, that is h square, is equal to the sum of square of that plus square of this side. See, a square plus b square, that means the length of this side AB is a, or in other order we can say that AC square is equal to AB square plus BC square, like that. So we have some of the example, like if we have the length of the three sides as 5, 3 and 4, then we can easily see here, it is 5 square is equal to 3 square plus 4 square. 5 square means 25 and 3 square means 9 and 4 square means 16. So if we add those, 9 plus 16 is equal to 25, which is equal to this 5 square. Again we have another relation here. 10, 6 and 8 are the sides of a triangle, and as this relation is satisfied, that means the greater square of the greatest side is equal to the sum of the squares of the other two sides. Like 10 square, that means it is 100, and it is equal to 6 square, that is 36, plus 8 square, that is 64. 36 plus 64 is 100. So the relation is satisfied, that is s square equal to a square plus b square. So this is according to the Pythagoras theorem. We will say that the triangle with these sides 10, 6 and 8 is a right angle triangle. So here the sides with this 5, 3, 4 or 10, 6, 8, if the triangle have those, if a triangle has those sides, then it is said that those numbers are the Pythagoras triplet. Okay, and they are always beside of a right angled triangle, remember that. See here, if we have the side like that and these sides satisfy this relation, then it is must, the sides must be the side of a right angle triangle, as it is mentioned here at the last line. Now see, we will go to the exercise 12. The first question you can solve, because it is based on the Pythagoras triplet. You have to find out whether it is right angle triangle or not by satisfying this relation. So you can easily solve question number 1. Question number 2 is also easy, but the explanation is done here. See, the question is written here. You can also read the question in your book. It is said that this one is the ladder, and it is the ladder is here on the support on this wall, and it is somewhere at the height h. It is considered as h, and the ladder foot is from is 66 meter away from the wall. So we have the lengths, like this one is the hypotenuse. If this one is considered as a triangle, as a right angle triangle, this one is hypotenuse and this one is the one of the side. So we have to find out this side. So we can take h square plus 6 square is equal to 10 square, and we can solve and get the answer. See the next question number 3 I have not solved, because it is also a easier question. You should try this question. And the question number 4 is also not solved, but the hint is given. The figure is drawn. You can easily understand the figure. Two poles of different height, like 6, it is given that 6 meter and 11 meter. So this one is 11 meter, as you can see, and this one is 6 meter, and the distance in between those is 12 meter, as given in the question. So we can consider here the distance is 12 meter. And now see this section only. This section is now become a right angle triangle. Okay, so we can use the Pythagoras theorem to find out this d, this length d. And remember that this length, it is clearly written here, this length is 11 minus 6. This total length is 11 and this is 6. So 11 minus 6, this length can be taken as 5 meter, and we can solve. So we can take like d square is equal to 12 square plus 5 square, then we can get the value of d square. That will be the answer. See the question number 5. Hint is given only. We have a side, a hypotenuse is given, and the ratio of other two sides are given as 4:3. So let us assume one of the side is 4x and other side is 3x. And now hypotenuse is also given, so we can use the Pythagoras relation. Like we can take 20 square is equal to 4x whole square plus 3x whole square. Then we can find out the value of x by using the idea of algebra. So you should do this one by yourself. And the next question, question number 6, is also of same kind. You also can take like whatever the ratio given, you try to solve question number 6 by your idea. Okay, now we have question number 7. The solution is done here. First see the question. You have in the question two cities A and B. Okay, and the distance from A and B is to be covered via C. That means whenever someone riding from, or someone starting from A, he has to be go to C and then after to A. So this length from A to C is given 2x and C to B is given 2 whole x plus 7. It is given in the book. And this one is also given. This AC is perpendicular to CB. So we have now a right angle triangle, and this one is one of the side, and this one is other side, and this one is hypotenuse. So we can use the Pythagoras relation as it is done here. This side square plus this side square is equal to that square, and the solution is done here. This complete algebra, and finally we have found this x is equal to minus 12, which is not possible. This is not possible because the value of x should not be minus, or if we put this one as minus, so it will be 2 into 12, that is 24, and this one be okay, we are not taking this minus sign, so we are taking only this plus 5. Okay, here this x minus 5 is equal to 0, so we can take x equal to 5. So the distance via C, it can be taken as this 2x, that is 2 into 5, so 10, and this one is 2 into 5 plus 7, that is 12, so 24. Okay, so it is 34. And we will say that the distance less by, when this new road is constructed directly from A to B, the distance is less by 8 kilometers. Okay, now see the next question. Question number 8 is not solved. You should solve this question number 6 by your idea. And this one is question number 9. Hint is given here. It is the isosceles triangle. So in the isosceles triangle, it is given that it is a right angle isosceles triangle. So we can use the Pythagoras theorem, and here the two sides ABC and AC are equal, so you can take both the side as AC and then use the Pythagoras theorem. Now see the question number 10. Hint is given and figure is already drawn here. In the question number 10, it is given that the triangle ABC, AD is the perpendicular to BC. So this one AD is the perpendicular to this BC. Now we have two triangles, so we can consider those two triangles and use the Pythagoras theorem. For this triangle, this AB becomes the hypotenuse, and for this blue color triangle, this AC become the hypotenuse. So we can use those two relations, and then after try to find out whatever we have to prove. Now next question is 11. The hint is also given for 11. We can consider the figure will be like this figure, and the name of the triangles are different, so we can consider PDQ and triangle PDR. So try to do it by yourself. And for the question number 12, again we have the same kind of figure, and we have to draw the altitude AD on BC as it is given here. And in the question number 12 it is given that it is an isosceles triangle, so we will take this AB is equal to AC for this question number 12. But remember that this figure is for question number 10. We have the figure of the same kind, but the only change is that this AB can be taken, AB should be taken is equal exactly equal to AC. Okay, so we will take the isosceles triangle here for the question number 12. And the area, the formula for the area is also that all you know. Now I'm going to the question number 13. See, 13 number triple star is given here. That means 13 number question you have to solve by yourself. It is a very important question, and I have not given any hint for that question. So, but one thing I will tell you, you should draw the figure first, then get your idea. Question number 14 and 15, only the calculation part is there, so you should try to get the answers, and the figures are also given, so use the idea of Pythagoras theorem and try to get the answers for the question number 15 and 14 both. Now question number 16, see we have the figure like that. You can easily understand that there are two triangles. So the hint is already given here. The hint is only given. You have this AB, this total AB is 5 into AE, 5 into AE. So you can take this BE, this BE is equal to AB minus AE, AB minus AE is BE. So this 5AE minus AE is equal to 4AE. So you can take the length of this BE. While you consider this blue color triangle, you have to take this length BE. So you can take BE as 4AE. Or it is better if you take X in the place of AE, then find out the X, then replace the X with AE. So try to do it by yourself. Again, this BD length is also given in terms of AE. So you can take this BD to BC, see this BC plus CD. So BC plus CD is given 2AE. So BC is given 5, so 5 plus 2AE. If this AE as X, the length will be 5 plus 2X, and this length BE will be 4X. So this 4X and this one is 5 plus 2X is equal to use the Pythagoras theorem, and this one is given AC is equal to AD, so you can take AC square is equal to AD square. So now you have ED square. See, ED square is equal to BE square, that is 4X square plus 5 plus 2X square, 5 plus 2S whole square. And for AE, sorry, it is AC na, so you can take AC as this AB square plus BC square. So try to do it by yourself. Now see the next question. It is not the next, it is the bit B for the same question 16. In this question we have a figure. You can see the figure in the book. I have just taken the two different triangles in two different places, but those two figures are on the same. Here you can see in the book, this figure you can see in the book. Okay, first I am considering, that means we are going to consider this triangle ACD with the right angle at the point C. So we can use the Pythagoras theorem, and here this DC is taken on the right hand side, because whatever we have to prove, in the proof part there is nowhere DC. So that's why I have taken out this DC in one side, and this one is marked as equation 1. Now for this bigger triangle, when this BC is taken, so in the place of BC I have taken twice of DC as it is given in the question. In the question it is given that this BC is equal to 2 of DC. That means for BC, D is the midpoint, so we can take DC. BC is equal to 2 into DC, because D is the midpoint of BC. Okay, D is here somewhere at the midpoint here in BC. You can see in the baseline BC. Okay, so now after putting this one BC as 2DC, we have this one AB square minus AC square is equal to 4DC. Now we all know that DC, the value of DC in terms of AD and AC, we can replace from the equation 1. Putting the DC from equation 1, we can get the part that we have to prove. So this is done with question number 16b. So this is all for today. Thank you, class.